2B. 5.2 is broken into two parts. We did 5.2A the other day. We're going to do 5.2B today. And 5.2B is scientific notation. And you guys ever did scientific notation?
Yes.
Yes? Okay. In a science class is where you use this a lot. You don't, I mean, in math you also use it, but you use it there more than anywhere else. And what scientific notation does for us is it lets us take great big numbers that do not fit on our calculators or do not fit in mathematical stuff that we're working with, and lets us take them and break them into something that will work and that we can work with. It also lets us take really, 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 really small numbers and break those into something that we can work with. The rules for these are pretty much the same. The first one is move the decimal point so that only one number is in front of it. So only one number is going to be in front of it. So where's my decimal point in this gigantic number?
At the end.
That's the tail end. So I'm going to take that decimal point and I'm going to move it all the way over to there. So that leaves me with 9.6. In my decimal, I'm going to move it all the way over here. That's going to leave me with 3.7. So I have 9.6 and I have 3.7. So that's the first step. So we got that part done. Step 2 is count the number of spaces you moved the decimal point. And if a whole number, it is a positive value, and B, if a decimal number, it is a negative value. Yep. So how many places did I move it? It's kind of hard to count from where you guys are sitting at to how many I moved it in the whole number. But I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spaces. And in my decimal, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but it's going to be a negative 11 spaces because I moved it back. This one I moved forward, this one I moved back. And then what happens with those is step 3, place the number from step 2 as an exponent on a base of 10. So my true scientific number for this long whole number is really 9.6 times 10 to the 16th power. Bless you. And my decimal one is times 10 to the negative 11th power. And these tell me whether I have a whole number if it's positive. I have a decimal number if it's negative. Okay? So that's what tells me the difference between them.
So when you mess with the stuff on the calculator and it gives you like the number and the E
Yeah.
negative, what's that mean?
The E means the times 10.
Oh.
So on your calculator, if you get one of these scientific numbers on your calculator, usually they give you 9.6 with an E, and then they will give you the exponent if we looked at the one we just got done doing. And what this E means is times 10. This 16 at the end is the exponent. Okay? So if that's what I had on my calculator, I really have 9.6 times 10 to the 16th power. Okay? If on my calculator I have 3.7 e to the negative 13th, that means I have 3.7 times 10 to the negative 13th power. So all it's doing is replacing that 10 with the e. So that means it's an exponent that you're working with. Okay? Does that make sense? All right. So now, what if we had 7 0 0 0 0 0 0 0 0 0 0, and I'll put my commas in here. That'll help you out to count with. And I said I'd write you a check with that amount of money, but you have to have your check written in exponent or in scientific notation. What would I write?
7.0
0 times 10 to the.
I can't do it when it's not like that. I mean,
Well, there's 3. There's 3. Yeah, I know it's hard when it's not in front of you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because it's a whole number, it is a positive 10. Okay? Make sense? Hopefully. Okay. Continuing with some more scientific notation stuff. If we have 0.00000476, and I want to write that in scientific notation, what will I get? So, move the decimal point back. So I have one number in front of it. And because it's a decimal, my exponent will be negative. And again, it's hard when you're sitting back there because you can't touch it to know where you're moving stuff to. So it's 1, 2, 3, 4, 5 places back. So my answer is 4.76 times 10 to the negative 5th. Okay or not okay? Okay? Good. All right. Now, they don't leave it just like that. In Hawks, they give you something that looks like this: 0.00512 times 57000 all over 0.00019. And they say solve it. Come up with an answer. Well, this one's small enough I could stick all this right on my calculator, multiply the top part out, get that answer, divide it by the bottom, and have what I would have for my answer. But if we put in scientific notation, 1, 2, 3 back, so I have 5.12 times 10 to the negative 3rd. Second one, I have 5.7 times 10, 1, 2, 3, 4, 5 back, positive 5. All over 1.9 times 10, 1, 2, 3, 4, negative 4. And so what I can do with this problem is I can break it apart. My exponents, I can just do those as I've been doing them. Negative 3 plus 5. What's negative 3 plus 5?
2.
Minus a negative 4. Nope. Out of here, I ended up with 10 to the positive 2, all over 10 to the negative 4. So 2 minus the negative 4, or that 4 is going to come up on top, so 2 plus 4. 2 plus, no,
2 plus 4
is
6.
6. So my exponent pieces of this is 10 to the 6th power. So I've combined these together. I took these two and added them. Then I subtracted that one because it's a division, and I got 10 to the 6th power. Then I need to go back and do my multiplication. So 5.12, so take your calculators and put 5.12 times 5.7. Get that answer. Divide it by 1.9. Get that answer. And that happens to come out to be 15.36 times 10 to the 6th power. But what does my rule of scientific numbers tell me? Can I leave it like this? What do you think? Can I leave it like that? type it in Hawks, 15.36 times 10 to the 6th power, hit submit. What's Hawks tell me?
Wrong, because you have
Not reduced or not in full scientific notation, because my rule with scientific notation is I can only have one number in front of it. When I move that over, that gives me another 10 to the 1st power because I moved it one place. So really, my true answer is 1.536 times 10 to the 1st plus 6 is 10 to the 7th power. Okay. So that's what I had to put into Hawks, instead of putting this piece in, because it's not simplified far enough. So you want to make sure that you move your decimal point stuff over.
Alright,
Okay?
yeah, redo that. Just say what you just said.
Okay, I can do that.
You know what I mean?
Just go back over this whole problem.
You add,
Okay.
you add.
You want to go back to the original part, or just this part?
Just do a quick brief summary.
Okay, brief summary. I first took this problem,
Yeah.
turned every piece of it in scientific notation.
Yeah.
So we know we did this and moved it over, and that's where this came from. I took this one, moved it back, and I got this thing. And I took this and moved it over, and I got this thing. Okay? So then I went through, because I have exponents, I went through and combined those. Negative 3 plus 5 is a positive 2. Because this is dividing, I'm going to minus a negative 4. So negative 3 plus 5 minus a negative 4. That is the exponents that are on 10. So negative 3 plus 5 is a positive 2. Positive 2 minus the negative 4. These signs change. So 2 plus 4 is 6. Okay? So I got 10 to the 6th power. Yes or no?
I think you lost right here.
I lost you right there?
Yeah.
Okay. All I did was, these two are on the same line, right? They're on top of it with the top part. My rule says that if the exponents are together and they're the top and the bases match, I add my exponents.
Yeah, that makes sense. That makes sense.
So a negative 3 plus 5
Yeah.
is 2. We all agree? But this bottom one is dividing it. So my rules for division, or the quotient rule, says I need to subtract it. So then I subtract it from what was on the top. This gave me 2 minus a negative 4, but this signs change back to chapter 1. 2 plus a positive 4 is 6. Okay? Then because I worked with my exponents, I can cross that piece off, and now all I need to do is my numbers. 5.12 times 5.7. Put that in my calculator. Got that answer, divided it by 1.9, and got this.
Divide it by 1.9.
Yep, because this big bar means to divide. So I'm dividing by 1.9.
All these rules switch around so much I can keep track of what I'm doing.
But I'm dividing because that bar means to divide in there. And I get my answer. But my answer isn't right because it's not in full scientific notation. I've got the exponent on base 10, but this has too many numbers in front of it. So I need to move it back one space. And so I end up with 1.536 times 10 to the first, because I moved it one space over. And then I need to combine it with the other 10 to the 6th, which that's where the 10 to the 7th came in at. And in changing it. Okay. Let's look at another one. So I think the more of these we end up taking a peek at, the better off you guys might be with those. So how about 6.3 times 4000 all over 0.0002. Let's see what we get with that one. So numerically, I could just take those numbers. I could just stick them on my calculator as they are, 6.3 times 4,000. Get that answer, divide it by 0.0002, and hit and get that answer, and I get something like let's see, 1, 2, 3, 4, 5, 6 zeros and 126. Okay, that's if I do it that way. This isn't in scientific notation, so how do I get it to scientific notation? Move my decimal point over. I move it 1, 2, 3, 4, 5, 6, 7, 8 places. And so my answer is 1.26 times 10 to the 8th power. Now that's if I didn't turn this into scientific notation first. So let's do it with scientific notation. So do I have to do anything with 6.3? Or is it okay? 6.3 okay? 6.3 is fine. 4,000 scientific notation is 4.0 times 10 to the 1, 2, 3. And it's a positive 3 because it was a positive number. All over 1, 2, 3, 4 back on that one. So 2.0 times 10 to the negative 4th. So then I have no exponent here. 10 to the 3rd minus, because it's a division, a negative 4. So 3 minus a negative 4. What's that going to give me?
3 plus 7.
Which is?
7.
7. So I 10 to the 7th. Multiply just the numerical pieces here. So I'm going to put 6.3 times 4. Divide that by 2. And I get 0.
Well, I guess it's 12.6.
Get 12.6? Okay. Something happened to mine. Oh, I see what happened to mine. 6.3 times 4 divided by 2. Yes, I get 12.6 times 10 to the 7th. But is that okay? It's not okay because this has got to go over one spot. So really I have 1.26 times 10 to the 1st, just adjusting this, times 10 to the 7th, or that goes right back to 10 to the 8th and 1.26. Okay? So two ways of doing these. One is to stick them on your calculator and go through and do them that way, or do that combination of turning them back into scientific notation and see what happens to them with that. Another one. We'll do another one of these. I don't know. Do the one story problem that shows up in your exercises with this. 0.058 times 0.0042 all over 0.58 times 0.014. What's going to happen to that thing?
Yeah.
If you put it on your calculator just as it is, and you could do that. Clear screen here. 0.058 times 0.00042. Enter equals, because I want to take that answer, and I want to divide it by, put the bottom inside of parentheses, because this has to multiply before I do my division, divided by 0.58 times 0.014, parentheses, hit enter, and I get the answer of 0.003. But if Hawks says put it in scientific notation, and I put this into Hawks, it's going to say not in scientific notation. So I need to adjust it over 2, or 3 spaces I should say, and end up with 3 times 10 to the negative 3rd.
Can't we do it without,
Yeah, we'll go do it that way, without putting it in there. So if we did it without putting it in your calculator, the way we just did this, I just put it in as it is, and put it in scientific notation, move it back to, so I have 5.8 times 10 to the negative 2nd. Move this back 4 spaces. Move this back 1 space. Move this last one back 2 spaces. Now it's all scientific notation. Okay?
I kept putting it in my calculator and I'm like, why the heck isn't this working? I wasn't using the parentheses.
Be careful with that, because if you don't put parentheses around this bottom after you figure out your top, it will divide by this and then multiply it by that, not divide it by these two multiplied. So be real careful, because your order of operations says multiply what's in the top, multiply what's in the bottom, then divide the two. So you've got to regroup stuff. -2 and a -4 leaves me with 10 to the -6 on top. And when I've got doubles, top and bottom, I like to do the top piece, then do the bottom. -10 to the first and a 10 to the -2 gives me 10 to the -3rd. And these are divisions, so it's a -6 minus a -3, or a -6 plus 3, or -3. And again, that's all chapter 1 stuff. It's coming back and doing that.
Okay, so what if, like, you have, for instance, like, final answer 0.07875. Would you just do it as 7.8 to the negative, or what? Yeah, would you just do it 7.8 to the -2, or would you
10 to the -2nd. No, 10 to the -2nd. If it's, you moved it only 2 spaces.
Yeah, but it's 0.07875.
That?
No, 0.07875.
Oh, okay. When you turn that to scientific, you move it back 1 space.
Yeah, but that's what I'm saying. How do you write your
Or 2 space.
7.8.
7.875 times 10 to the -2nd.
Yep.
Okay? Because it's got to be turned back into scientific notation. Okay? So let's see if we get our 3 out of this. 5.8 times 4.2 equals, divide that by parenthesis 5.8 times 1.4 parenthesis, and we do get 3. Where's what? Oh, I put my values together. So were you okay with this part of getting the... Okay, so 10 to the -3rd is what we got out of our exponent. Then I went 5.8 times 4.2 on my calculator. Got that answer, hit equals. Then I divided, because that's what the bar means, parenthesis 5.8 times 1.4, because this multiplication has to happen before it divides the top.
Right.
And then when I did that, I ended up coming up with 3.
So then you just add the...
So my answer comes out to be 3 times 10 to the -3rd.
Okay, will Hawk accept it, or do we have to put 3.0 times 10?
Should accept it
Okay.
without a decimal point 0 in there. You don't need the 0 because it's just there, so you won't need the 0. You should accept it just like that. Yes or no?
Yeah. Yes.
We're good? You think?
Do they get any harder than just the...
Nope, that's all they do with them. They don't get any harder. The only thing they do end up doing is they give you one type of story problem. And this story problem, I think, is on your test. And that one type of story problem is that an atom of gold has a mass of 3.25 times 10 to the -22nd. So 3.25 times 10 to the -22nd. That is one atom. So only one atom gives me that amount. It says, what is the mass of 3,000 atoms of gold? Express your answer in scientific notation. So what would I have to do? Well, if I've only got one and it's worth this amount, but I want 3,000 of them, what would I have to do? Multiply, yeah. I'd have to take 3.25 times 10 to the -22nd and times that by 3,000 because I want 3,000 of them. So I'd turn the 3,000 into scientific notation, so what does that equal? 3,000 come up to equal in scientific notation.
3.0
Uh-huh.
times 10
To the third. Beautiful. Yep. Times 10 to the third. And that's all going to be multiplied by 3.25 times 10 to the negative 22nd. So I need to put my exponents together. So negative 22 plus 3. What's that going to leave me with? 10 to the negative 19th, I think. 22 minus 3 is, or negative 22 plus 3 is a negative 19. So what's 3.5 or 25 times 3? 3.25 times 3?
9.75.
Perfect. And that's my answer. So that's my scientific answer, notation answer. Now I can't just stick this thing on my calculator because of that negative 22. You can, in your calculator, there is a EE key, which is right above your comma on your keypad. That lets you put stuff into scientific notation. So if you wanted to put this thing into your calculator, you would go 3.25, go second, your EE or your comma key, and it puts that little E in there, like would show up if you put scientific notation on your calculator, a negative 22 times 3 second EE, and we said we had a exponent of 3 on my 10, and if I hit enter, I will get my 9.75 e to the negative 19th that we said it was equal to. So you can use your EE key as well.
Okay, wait, 9?
Okay.
Mine tells me I got a great one for you, Marcel.
You got a great one? Okay, what is this one?
Well, not that good. Parentheses.
Parentheses.
5 times 10 to the negative third.
Mm-hmm.
And then outside of the parentheses times 552. No parentheses for that. Just 500. Well, I guess it don't matter.
Doesn't really make a difference.
No, 552.
552?
Yes.
No zero.
No zero.
Okay. 552. Mm-hmm.
Over parentheses 5.7 times 10 to the 6.
Okay.
Times another thing in parentheses 2.3 times 10 to the 4.
Okay.
Do you?
So what would I have to do?
I thought you.
These are all scientific. This one isn't. So what would it be as scientific if I wrote that one again? So 5.25 times 10 to the 10 to the second. Mm-hmm. Yep. So now all I need to do is go through and do what I've just been doing. Take all of my base 10s and combine them all together. Negative 3 and a positive 2. Mm-hmm. And if I do that, I'm going to do the top piece first, then do the bottom. 6 plus 4 gives me 10 to the 10th. So, because this is a division happening, what's going to take place? Negative 1 minus 10. What's that give me? Negative 1 minus 10? Negative 11. Mm-hmm. So I have 10 to the negative 11th as all of my exponent pieces, so I can just cross those all off and then do my number part. So 9.5 times 5.25. Or 9.5 times 5.52, I think I said it wrong. That gives me 52.44. The bottom, 5.7 times 2.3 gives me 13.11. Then I need to take those two and divide them. So 52.44 divided by 13.11, and I get 4. So my final answer, because this was my to the positive, to the times 10 to the negative 11th. And that's my answer.
I guess it's just too much to throw that in the other side.
It's just follow the pattern. The pattern is get them all in scientific notation. Combine your base, your tens with whatever exponent you happen to have. Get that done. Then go back and do mathematically whatever it's asking you to do with your numbers. Multiplication here, but the bar in the middle meant I had to go back and divide them. It's just a matter of getting your multiplication stuff together with it. Okay or not okay?
Wow.
Alright. Again, it's practice. Make sure you go and do your practice. Don't hop into certify with this stuff, because you need to get down what you got to do of getting your values to end up working out. Okay? Moving on. 5.3 is looking at polynomials.
Wait, how in the heck was it before?
How did it get bounced before?
Yeah.
Oh, because these two multiplied together gave me this. So 9.5 times 5.52 gave me 52.44. 5.7 times 2.3 in the bottom, that gave me 13.11. And then I divided those two. So 52 and 44 hundredths divided by 13 and 11 hundredths gave me 4. That's how I got my 4. You see now? Okay. Good deal. All right. So that was scientific notation as far as getting that part together. In 5.3, we're dealing with polynomials. We've had polynomials ever since Chapter 2, but we never labeled them and never called them anything. A polynomial is something like x squared. It could be 2x plus 3. It could be 4x squared plus 3x plus 1. These are all considered to be polynomials. Or we could have 4ab plus 7ac minus 3ad plus 4z. Those are all considered to be polynomials because they have different pieces that are connected to them and what we happen to have with them. Now they're polynomials because they have terms, and the terms are the pieces separated by addition and subtraction. So, the terms of the first one only has one term. It only has x squared. The second one has a term of 2x and a term of 3. The third one has a term of 4x squared, 3x, and 1. And the last one has a term of 4ab, 7ac. If it's got a minus in front, that means that's a negative 3ad, and the last term is a 4z. So you've got terms. So they're separated by addition and subtraction signs. Are we okay? Yes? So, if you had 2x plus 3y minus 7, what are my terms of that polynomial? So, first term would be 2x, and a negative 7. Yes, that's my term. So those are my pieces of this whole thing. So the pieces in there are created by your terms that you have. Now within polynomials, there's names for these. The first one is a single term. It's called the monomial. So that's a monomial. Mono meaning one. Okay? So it has one term. The second one that I have listed up here is a two-termed. So 2, what do you think the polynomial name would be? Binomial. Yep. Binomial has 2 terms. 3 terms, that one's called a trinomial. Okay? Anything beyond 3 terms is simply called a polynomial. They didn't come up with any fancy names for anything that goes beyond 3. But these all have fancy names to them. And so you'd have to come up and know what your name happens to be. So if it's got 3 terms like this one down here, what would I call this one I gave you an example when we picked out terms in there? What would I call that one? That's a try. And in Hawks, it will list all of those, and you'll have to check which one it happens to be. So if you had the equation of 3x squared plus 7, and Hawks gave you a monomial, a binomial, and a trinomial, we would pick a, binomial, because it has 2 terms. Easy part right there, picking out what ones they happen to be and what their names happen to be with those. So you got just those basic ones. Now, one thing that a polynomial is not. So polynomials have to have exponents on them that are whole. So the exponents on any variable have to be whole values. Whole values meaning whole numbers, meaning I can pick 1 all the way up to infinity, but they have to be whole values. So if you were ever given x or 4x to the 1/3, just for polynomials, yep, they have to be whole values. So if they gave you the example of 4x to the 1/3 plus 3x to the 1/2, this is not a polynomial. Because I can't have fractional exponents. There can be no fractional exponents. Those force it to become radicals, and we don't deal with radicals in this class. We dealt with those. We'll do those in intermediate, but not in here. And those are not a polynomial. So if it said, what's the name of this? You would have to say it's not a polynomial. Okay? So you would check not a polynomial if they gave you that one as well. So keep that in mind that that's not a polynomial if it has fractional values in there. Okay? Any fraction? Not a polynomial. Okay? If it's got just solid whole values for your exponents, then it is a polynomial. So what if we had this one? 3x to the 5th plus 4x squared minus 2x plus 4. What would I say about it? What kind is it? It's just a polynomial, right? Yeah, no special name to it or anything. The next thing they mention in this section is degrees. And degrees are based on the size of the exponent. So the size of the exponent. So if I were going to get my degree out of that first term, and it goes by terms, use the term to figure this out. So if I were going to find my degree of this one, I'm going to look at my exponent. My exponent's 5. So the degree of that first piece is 5. That's the degree of the second one. 2. The degree of the third one? 1. And the degree of the last one? 1. But it doesn't have an x, so it really has a degree of 0 if you look at the fourth piece there, because there's no x. And the degrees are on variables only. So you don't, if you have a constant, that's what this term is called, a constant term. Because it has no variables. It stays as a 4 regardless of whatever we do to it. It's always going to be a 4, and so that part's not going to change at all. So you can pick out degrees. Saying like, what do you want to say?
Okay, let's just make sure I'm getting it. So we're just wanting to know right now what a polynomial is. Anything that has like an exponent,
Yeah, solid
Anything
exponent.
with exponent will make it a polynomial unless it has a fraction
As a
exponent.
exponent, yep. Then it's not a polynomial.
And the degree is what the exponent, the amount that was.
Right. Yep. Yep, the degree
Okay.
is whatever this thing happens to be on there. So if we had 7x to the 4th plus 2x to the 3rd minus 8x to the 5th plus 2x, what is the highest degree in this polynomial? This one's a 4, this one's a 3, this one's a 5, this one's a 1, so the highest degree is 5. Yep, just getting a little close there. Equals 5. Okay?
That would be the leading coefficient.
The leading coefficient. Now we gotta talk about that. Okay. The leading, yeah. You just kind of put the words in my mouth there, Shelley. It just kind of flowed right out there, and that was the next thing we were going to talk about, because we're going to get degrees down first. We got that? Okay, we okay with degrees?
Yeah.
Yeah. Now, the leading coefficient. The leading coefficient is the coefficient on, coefficient meaning the number, on the highest degreed term. So, what would be my leading coefficient? It would be a, what kind of 8 though? Negative 8. Yeah, negative 8. So my highest degree would be my leading coefficient. We also need to put these things in descending order. Descending meaning I'm going to go from largest degree to smallest degree. So if I'm going to put my example up there in descending order, what would I get? So, negative 8, x to the 5th comes first, followed by, what's the next highest degree? What was it? The 2? This one? Highest degree, yeah, plus 7x to the 4th, followed by, what's the next degree?
2x to the 3rd.
Plus 2x to the 3rd, yep, followed by plus 2x. That's descending order. When you have descending order, these the exponents that are on here will be in descending order. 5, 4, 3, 2, or 5, 4, 3, 1. They're in descending order because they're going from the largest down to the smallest. Okay? So from the largest degree to the smallest degree is what we get in descending order. So here's another one. Let's see if we can find all of the information on this one. So if I gave you this, negative 8x to the 3rd plus 2x to the 7th minus 3, and I asked you, what kind of polynomial? What kind is it? Trinomial. What is its highest degree?
7.
Okay. What is its leading coefficient?
2x.
Okay. You guys said 2. You don't have to put the x to the 7. You just have to have the number that's out in front. And if I want to put it in descending order.
2x to the 7th plus 8x to the 3rd.
Yep. That's descending order. Okay. That's all that's basically in this whole section. He's asking you to do is to get degrees down, to get coefficient stuff down, to figure out whether it's polynomial or not. And that's basically all that happens in that part, is just going through and ask you to do that stuff. They do ask you to replace letters with a number, so they might give you the function of f of x equals 2x squared plus 3. What kind of polynomial? By, because there's 2. The leading coefficient? 2. Highest degree? 2. Numerical coefficient? 2 and 3 are my numerical coefficients, and this one happens to be that 3 is my constant term at the tail end of it. And then they might give you something like what happens when x is replaced with 3, and we did these in the last chapter because we had to come up with all those different points. So what that means is I'm just going to take 3 and replace x with it. So 2 times 3 squared plus 3. What would my answer be?
Uh,
18 plus 3?
21.
21. Perfect. Yeah, get 21 out of it. That would be my answer. They also, though, give you things like that, where they say a plus 2 is what x happens to be. So what has to take place with this one? Well, that means wherever I have an x, I gotta give you something without a square in it, though. So if we had f of x is equal to 2x plus 1 as my number, I would replace x with a plus 2, and then do as much of the math as I possibly can. 2 times a is 2a. With my distribution, 2 times 2 is 4. So my final answer is 2a plus 5. Would be what I get with that one. Okay, so 2a plus 5 will be what I get, and what that happens to come out to be. And so that's what happens in that section. Not bad?
Marcel,
Yes.
can you do a problem?
Sure. Where are we heading back to?
I'm really not confused because you got add numbers. Polynomials.
Okay, what do we got?
Alright, you got the starting off problem is negative 2x squared plus 8yx squared minus 4yx cubed. And you got to replace the variables. Y equals negative 3 and x equals 1.
Okay.
I can get it broke down, but having
Okay.
to solve it is becoming
Okay.
an issue.
Well, let's put it all together. What's it telling me? Well, it's telling me I need to square my x in the first one. You said it's a negative 1 or positive 1? What's x?
Positive 1.
Positive 1? Okay. So I have a negative 2 times 1 squared. All I'm going to do is replace my letters with my numbers.
Yep.
Plus 8. This all means multiply. So it means 8 times a negative 3 times 1 squared, positive 1 squared, minus 4 times a negative 3 times 1 cubed. Okay. Now we're right back into chapter 1, I think, is where we're in order of operations.
Yeah, I know it's stupid,
Okay.
but I...
So let's go through and figure out what we gotta do. Well, order of operations says I need to do what's inside parentheses. So I have math inside of my parentheses. I don't. There's just solid numbers in there, so I don't have any parentheses. But I have exponents, so let's take care of those. So, what's 1 squared? 1 times 1 is 1. 8 times the negative 3, 1 squared is 1 as well.
But you're gonna, oh.
And what's 1 cubed? 1 times 1 times 1 is what? 1?
Well, wait, didn't you say it was negative 4xy cubed?
Negative 4yx cubed.
I've got it written. Negative 4yx cubed, she said. So, we got it written down, right? Finish it. I just got to do my multiplications. Negative 2 times 1 is a negative 2. 8 times a negative 3. What's 8 times negative 3? Times 1? Negative 24. Negative, or 4 times a negative 3 is a negative 12. Times 1 is a negative 12. Okay. Then go back and do my adding and subtracting. A negative 2 and a negative 24 is a negative 26. Change my subtraction, change my sign. Negative 26 plus 12. Yep.
I think it should be overwhelmed.
Well, because it has the polynomial stuff we've been talking about. It has plugging in a letter, and then it also has order of operations. So it's got kind of like almost everything we've talked about in algebra in one problem. That's why. But you got to do it step and piece by piece by piece by piece. But again, it's plugging this stuff in to your problem to make sure that you get your correct answer out of it.
I have a question.
Yes.
It's probably going to be real simple, but it's one of those polynomials. But one of them is the actual equation is Tx is equal to a negative 2.
Tx, T as in
Yeah.
Tom? Tx, yes.
Is equal to a negative 2x minus 4, and then the polynomial or whatever is a plus 3. And I can't figure it out.
So that's what I'm replacing the x with. This is t.
Or t.
So this replaces the x, so I'm going to have a negative 2 times a plus 3 minus 4.
Okay.
So then 2 times a negative 2 times a is a negative 2a. Negative 2 times a positive 3?
Yeah, negative 6.
And then I just got to combine the stuff I can combine. Well, the pieces I combine is a negative 6 and a negative 4 will be
A minus 10.
Yep, and that's my answer.
Okay, well, I guess I was doing it right then.
Yeah, this means it's a function. If you have t of x, when you got inside parentheses, that means this is a function. So what's taking place with this when I throw in a plus 3? So if I were going to replace that x and stick this piece in its place, what happened to it? And what happened to it is as I worked through it, it became this. Okay? Yep. Anything else? Okay. Last section for this time is going to be 5.4. And we did this back in chapter 2, I think it was, where we had something like 2x plus 3y plus 4x minus 2y. And what we did is we combined like terms. And when we did that back in chapter 2, we had to go through and find like things. They had to match each other by variables. And so when they matched each other by variables, we took the numerical coefficient, the number out in front, added them together. So 2 plus 4 is 6. The x we did not square because that's its label, so it just came along as an x. Then we looked at a positive 3y and a negative 2y, and what happened?
Plus 1.
Yep. And I ended up with a plus y. So we combined like stuff and stuff that matched each other. So in this section, in 5.4, they might give you 2x squared plus 3y, or 3x plus 7x squared minus 2x. Now they all have x's, but do they match each other? Can I put all that together? What do you guys think? Nope. This x squared and this x squared make these different than these single x's. So it's kind of like throwing a whole bunch of different apples in a basket. You need to sort out all the red ones and leave all the yellow ones and sort out the green ones because they're all apples, but they're all different kinds of apples. So you got golden delicious and you got red delicious and you have Granny Smiths in there, and you got all these different types of apples, but you sort them out based on whether they match. So this matches this. So 2 plus 7 is 9x squared. 3x and a negative 2x is a plus x. So my answer becomes 9x squared plus x. Okay. So when they say they got to match to be identical to each other. So if I had 2x squared y plus 3x plus 7x squared z minus 2x, can I stick these two together now?
Yeah.
I can?
No.
No, because the y and the z made them completely different. So you have to be really careful and make sure the numerical part doesn't have to match, but the variable parts have to match. So they got to be identical to each other.
The x squared stays as x squared.
Yes.
You don't add the 2 to
I can't. I can't put these two together anymore because one's got a y and one has a z, so they're different.
So the final answer would be 2xy squared plus the 7x squared z plus x.
Yep. Yep, that would be my answer. Yep, because I cannot put these two don't match each other anymore. They're definitely different from each other, and so they don't match, so I can't put them together. In section 5.4, they give you two polynomials, such as 2x plus 3 plus 4x minus 2, and they say put that together. Well, if you are adding, you are actually saying I'm distributing everything inside of there by a positive 1. But when I multiply something by a positive 1, does it change it in any way?
No.
Nope, not at all. So 3x, or 2x, let's hope I write it right, plus 3. 1 times 4x is a plus 4x. 1 times a negative 2 is a negative 2. And now I'm back to where I was in chapter 2. So if you are adding, you're going to just drop the parentheses and add like terms. So 2x plus 4x is 6x. Positive 3 and a negative 2 is a plus 1. And so my answer comes out to be 6x plus 1. We okay? So far? What do you think? Yeah? So basically it's just dropping that piece and coming up with what you would have with that. So what if we had...
second part.
What was that?
You're only doing that to the second part.
Yes. First part I can drop my parentheses there too because that's just what I'm given at the beginning. So how about this one? 4x squared minus 8x plus 8 in parentheses plus negative 7x plus 2. What happens to it? Oh, drop my pieces. Gives me a negative 7x and a positive 2. So what comes out of all that when I'm all done putting it together?
You can do the negative 8x and the negative 7x.
Uh-huh. Can I do anything with the 4x squared?
Nothing, because there's not
Nope.
enough 4x squared.
But when I put a negative 8 and a negative 7, I get a...
Negative 15.
And can I put this and this together? Yep. 8 plus 2 is 10, and so my answer comes out to be 4x squared minus 15x plus 10. We were using this in intermediate algebra today because we were combining like stuff to get what's called, this is intermediate, it's called a quadratic, but we were combining stuff together and doing the same stuff, so that rules and those things we learned way back in chapter 2 still play a role in everything. Now, addition's great because you just drop everything and just add it together. Subtraction, on the other hand, you need to do a little extra work in there. In subtraction, you need to change the sign on each value inside the parentheses that is being subtracted.
So you make it adding.
Yep, you turn it into an addition problem. To make it an addition problem. Yep. You guys are being good today. You're kind of getting it out of me before I put it down here. That's good. You're getting these things in there. You're starting to think about these things. What that means is if I have a negative times 2x minus 4, this negative out in front of here is a negative 1. So that means I need to distribute or multiply each piece by a negative 1. So negative 1 times 2x becomes a negative 2x. Yep. A negative 1 times a negative 4 becomes a positive 4. So be really careful with your signs. This is kind of the only spot in here that makes it bad, is you might mess up a sign. So keep track of your signs. So with that negative out in front, it just needs to change my signs, and then I can put stuff together. So in other words, this might look like 3x minus 4 minus 2x minus 4 as a problem. So the 3x minus 4, nothing happens to it. It stays as it is. This piece, though, becomes a negative 1 times 2x is a negative 2x. Negative 1 times a negative 4 becomes a positive 4. And now I'm back to addition. So what do I have to do? Get that one to work.
Wow. I just, for my answer,
One X.
Just x.
Yeah.
All you can have is just x, because 3x minus 2x is x, and a negative 4 and a positive 4, long gone. They cancel each other out, so that ends up being your final answer to that thing. So you can't change that piece. What about this one? 5x squared plus 3x minus 3x squared plus 2x. What happens to it? I'm in subtraction. What do I need to do?
5x squared plus 3x minus 3x squared minus 2x.
Yep.
Then you get 2x squared minus, or wait, plus x.
Plus an x. Yep. So 2x squared plus x is what we get out of that. So it's kind of go through, change some signs in here, and kick out an answer of what you can have with that one. So you kind of got some combinations of stuff there when you start changing your subtraction things. They do, in Hawks, do this number to you, so just so we're aware, and we see one. 4a minus bracket 4 times a minus 4 plus 5a plus 3 and a bracket. Now, order of operations, I better not wander, I need my microphone over here. Order of operations in here says that I need to take care of what's inside of my bracket. Can I do anything in there?
Yes.
Yeah. So I'm going to take anything I do not work with, which is the 4a minus whatever's in there, but I can distribute 4a times a, or 4 times a is going to give me 4a. 4 times a negative 4 is going to give me a negative 4, whoops, or negative 16, sorry. Plus 5a plus 3. Now, what's inside of this bracket, what can I do with it? Well, I got some combining in there to do, don't I?
Yeah.
So if I combine 4a and 5a, what's that give me?
9a.
Negative 16 and positive 3?
Negative 13.
That's still inside of brackets. Then I need to finish it out, because now I've got a subtraction happening here, so that negative 1 needs to be multiplied by every piece. So I have 4a minus 9a. Negative 1 times a negative 13 is a positive 13. Put stuff together, 4a and a negative 9a.
Negative 5a.
Plus 13. Yep. And that will be my answer. Okay? Alright, what do you think? Yes or no? Can you do those? Okay. And this is about as difficult as it gets in that section, when you've got to clear something else out inside of those. But otherwise, it's just watching and making sure if you got a subtraction, change the signs on everything after it within that. Okay.